Okay, 42. Of the 517 graduating seniors at Brighton High School, approximately 4/5 will be attending college, and approximately half of those going to college will be attending a state college, which is the following is the closest estimate of the number of graduating seniors who will be attending a state college. Okay, so let's start with the little tree here, and our total that we're dealing with here is 517. Now this 517 is going to be split up into two categories. One category is those who are attending college, and the other category is no college. Okay. Now it looks like 4/5 of 517 is going this route, and then 1/5 of 517 goes this way. And we recall of means times, right? So let's calculate those numbers. 4/5 equals this. Of means times 517. 413.6. Okay? 413.6. Obviously you can't have 0.6 of a person, but that's alright for now. And then 517 times 1/5 or divided by 5 is 103.4. Okay, 103.4 goes this way. Now it says of the half of those going to college are going to state college. So from here we branch off again where we have half of 413.6. So to take half of that, we just do 413.6 and divide that by 2. 206.8. So that's how many are going to state college, and that's how many are not going to state college. So the answer would just be 206.8, which is closest to 200. Let x box y equal this. For all integers x and y, which of the following is the value of 5 box negative 3? Alright, so this is a rule just telling you what to do with those numbers. These are just placeholders or symbols to represent what sort of operation you need to do for the x and the y. Alright, so we just have to follow the format here. 5 box negative 3. Okay, so the 5 would go everywhere we see an x. So the first place we see an x is right there. So we put a 5 in. Minus 2 times y. Now y is negative 3. So that goes in there, and that whole thing gets squared. Okay, so again, x and y are placeholders for the numbers that are to follow. So the numbers 5 represents x, and the number negative 3 is representing by y. So we have to replace x with 5 and replace y with negative 3. Okay, so we've done that. Now, negative 2 times negative 3 is positive 6. Alright, so we got 5 and 6, which is 11. 11 squared is 121. Answer choice A. Alright, next, 125%. So 125%, you can interpret this one of two ways. Percent means divide by 100. Alternatively, instead of doing that, you can also move the decimal twice to the left, which is usually the option that I will end up doing. Then we have of, so that's times. Okay, a number usually means x, right? Some unknown. Is means equals 425. Okay, simple enough. So we got our nice equation to work with there. As a matter of fact, we could even solve it, right? So to solve it, we just have to divide by 1.25, and calculator will help. So 425 divided by 1.25, we get 340. So x equals 340. So the next part says, what is 65% of the number? So for what, we usually use x. Okay. We've already got an x involved in this, so we can use a different letter or even a question mark. In this case, I'll use y. So y is means equals 65%. So again, I'm going to move the decimal twice to the left. Of means times the number. Now the number means the original x that I was dealing with, which I can now replace with a 340. So now I could just simply calculate 0.65 times my answer. That'll give me 221. Okay, that's answer choice F. what is the distance in the standard xy coordinate plane between the points 2, 3, and 5, 5? Okay. So, the typical formula for distance is really, really ugly. It looks like this, okay? And the problem with this formula is that, whoops, x2, yeah, y2 minus y1 squared. The problem with this formula is that you can mess up in a lot of ways. For example, you can write a plus here instead of a minus. You can write a minus here instead of a plus, okay? You can forget to square these guys, okay? And you can forget to square root the entire thing. So there's many, many ways that you can cause a problem with this formula. So therefore, I never use it, okay? So I do it a little bit differently. I use a formula that might look familiar to you, okay? All right, this is just Pythagorean Theorem, okay? So how does this work? Well, instead of C, I use D for distance, okay? And then in A and B, I'm going to use delta x and then delta y. So delta x is a change in x coordinate. So I just have to find the difference of those numbers, which happens to be 3. And the change in y is the difference in the y coordinates, which happens to be 2. And so I do 3 squared is 9, 2 squared is 4, and then of course at the end I have to square root everything to get the distance. So the distance is going to be rad 13. Now in general, these numbers might be a little bit trickier. So let's take a look at one example of that. So yeah, let's go something like this. Now, in this case, right, my x value, when I'm doing delta x, it's not so easy because I have a negative involved, right? So I have to ask myself the following question. Do I cross 0? In other words, are these opposite signs of each other? So if the answer is yes, which it is in this case, what I have to do is I have to add the numbers because I'm going over 1 and then over additional 4. So I add their absolute values, meaning disregard the sign and then add the actual number parts. So 1 and 4 is 5. Now, on the other hand, let's make these both negative to just make things interesting. Now, if these are on the same side of 0, in other words, they have the same sign out in front, then I just have to subtract the absolute values, namely subtract the number parts. So 7 and 3, if I take their difference, I get 4, correct? So now I've got delta x and delta y. I simply have to use Pythagorean theorem with those numbers, okay? And I don't have to care about positive or negative changing. Whereas with the slope formula, I will care about whether they go up or down, okay? So I would have to put like a positive or negative depending on sort of the whether they go up or down. So in this case it would be up, so this would be a positive 5. And in this case it would be down because we went from negative 3 to negative 7, so it would be a negative 4. But anyway, we could disregard that for distance. 5 squared is 25. 4 squared is 16. So we end up with 41, and don't forget the square root. Okay, so this is another example of a similar kind of question with a little bit harder numbers. Okay. The ratio of the radii of two circles is 9 to 16. What is the ratio of their circumferences? Okay. So we need a circumference formula, and in fact we would like it to be in terms of radius. So the formula we're looking for is this: c equals 2 pi r. And then we want to inspect what the proportionality is between circumference and radius. So in this case we can detect that it's a direct proportionality. In other words, the variables are directly related. So what that means is if I was to double the radius, the circumference would double in response. Okay. And equivalently, if I sort of multiply by some weird factor to turn a 9 into a 16, in the input variable, the output variable will be multiplied by the same weird factor to turn another 9 into another 16. So I would say that they're in a 9 to 16 ratio as well. That won't always be the case, of course. So if I have a equals pi r squared as my formula, then the input variable is getting squared with respect to the output variable. So in other words, if I was to take r to, let's say, 3r, then the area would become, well, let's see, if I was to substitute a 3r in, that 3r would get squared, squaring both pieces inside, making it 9r squared. So that would be 9 times the original area, you see. So the effect would get squared, if that makes sense. So that's known as a direct square relationship, or proportionality. Right, a circle in the standard xy coordinate plane is tangent to the x-axis at 4. So here's your x-axis at 4. Tangent means it just barely touches, right? And it's also tangent to the y-axis at 4. So the circle probably looks something like that, right? Roughly. Which of the following is an equation of the circle? Alright, so the first thing we'd ask is, what is the center? So the center, it seems, is going to be over 4 and up 4. So the center is going to be at 4, 4. So the next question we'd like to know is, what is the radius? So as you can see here, the radius would be a height of 4. That matches up with the height on the y-axis. So the radius equals 4. Now we'd like to know what the formula is for a circle. So in general, it would be this plus this equals this. Alright? Now this might look like a really hard formula. However, one thing we could note is that it all sort of stems from Pythagorean Theorem in a way. So it has kind of a look of Pythagorean Theorem with a square plus a square equals a square. And this minus h and this minus k, they have to do with a shift in the coordinate. Okay, because normally we'd have x squared plus y squared is r squared. That would be a circle that's centered at the origin, 0, 0. But in order to shift it, we have to sort of minus this h by here. Now, the reason why it's minus, you could think of it in terms of sort of our transformation rules that we might be more used to in the context of parabolas. Okay, so this indicates a movement up by 3. It's a vertical shift, right? Whereas this corresponds to a shift to the right by 2. Okay, so this is a horizontal shift. Notice that it's inside the parentheses here, so it's affecting x directly, and also it's opposite sign than you would normally think. So minus we usually associate with movement to the left, but since it's inside the parentheses here, we remember that we have to actually switch the direction. Okay, that's a general rule, that if it's in parentheses, we switch the direction. Okay, and don't worry about why, because the reason why is actually not quite important, so long as you remember the fact that that's what's done. Okay, so again, here this is a shift to the right by h, and here this is a shift to the right. What would it be? Up by k. So again, this is a vertical since it's affecting y, and it's opposite of what we think. So instead of being down, which we usually associate with minus, it's going to be up. Okay. So anyway, since the center is 4, 4, we're looking for minus 4, minus 4. So we're down to these two. And then we need r squared on this side. So it's going to be choice D. Right, 48. Using the complex number I, where I squared is minus 1, what is this equivalent to? Okay, so the first thing I want to make note of is a lot of people think, okay, can we just cancel these? But then, of course, this is not a choice. So why are they even doing this in the first place? Well, if you recall, right, if you have something like this, you do what's called rationalizing the denominator. Okay, we don't like having radicals in the bottom, so this is how we sort that out. Okay, so we end up with rad 3 in this instance. Now, we can also explore a situation where we have a binomial in the denominator. So in this case, right, what we would do to remedy this situation is we'd multiply by what's known as the conjugate. Okay, so the conjugate has got a switch of the middle sign here, right? So on the bottom we'd have to FOIL. We get 1, the inner and outer will cancel, and then the last will give us minus rad 2 squared, and rad 2 squared is of course 2. Okay, so we get this, which equals sort of this. right? So anyway, we've gotten rid of the radical that was in the bottom. Okay. So now you might be wondering, how does this relate to this whole thing to do with i's, right? And so we'll discuss that now. Since I squared is equal to -1, if we square root both sides, we get I is equal to radical -1. So you notice that I is a radical. So this is not so different from what we were looking at just a moment ago. Okay, so we have basically got a radical in the denominator, but it's just given a different symbol. So that's why we're multiplying by the conjugate, okay, top and bottom. The effect is going to sort of help us get rid of the irrationality in the denominator, okay? So we start with first on the bottom. That gives us a 1. We do outer, 1 times I is plus I. Inner, minus 1 times I is minus I. And then the last is going to be minus I times plus I is minus I squared. Now the top is going to be 2 plus 2I. Okay? Now again, the plus I and minus I cancel. And then we have just 1 minus I squared, right? Now since I squared is -1, anywhere I see an I squared, I could place a -1. 2 plus 2I over 1 minus -1. So 2 plus 2I over 1 plus 1. So it's 2 plus 2I over 2. Okay. From here, you could finish it two different ways. One way is you could factor the top, factor out a 2. You're left with 1 plus I. Divide by 2, and these 2's cancel. So your answer is 1 plus I. The other way to finish it is to realize that this 2 is a common denominator for both pieces. So you can have it distribute to each one separately, and then you get 1 plus I. Okay.